numerical problem for processing two jobs through M machines. Okay, so this kind of problem can be solved by using graphical method only. So using graphical method, determine the optimal sequence needed to process job 1 and job 2 on 5 machines. Here we have 5 machines A, B, C, D and E. For each machine, find the job which should be done first. That is job 1 or job 2, that we have to find out. Okay, so each machine has to process job 1 and job 2. We have to find the order which job has to be performed first. That is the first question. And the next one is also calculate the total time needed to complete both the jobs. Okay, so here we have two different jobs and sequence of each job is given in the problem. For first job, this is the order A, B, C, D and E. Okay, so here the actual or expected processing time also given in the problem for each and every machine for job 1. And for job 2 also they have given the sequence, that is order B, C, A, D, E. This is the sequencing order and duration also given. For B, 5 hours and then 4 hours, 3 hours, 2 hours and 6 hours. Okay, so with this information, they're asking us to find out, that is determine the optimal sequence needed to process two jobs on 5 machines. For each machine, find the job which should be done first. That is job 1 or job 2. That we have to find out. Okay, and the second one is also calculate the total time needed to complete both the jobs. Now we are going to see the solution with this given information. First step, we are going to plot the graph from the given information. See the graph. Here we have two axes, x-axis and y-axis. X-axis denotes job 1 and y-axis denotes job 2. Okay, and I have used scale as 1, 2, 3, 4 like that. The same scale must be used for both the jobs. Here also I have taken 1, 2, 3, 4 like that. Suppose if I take 2, 4, 6 means I have to use the same scale for job 2. Okay, so scale use must be same for both the jobs. And I have taken 1, 2, 3 and 1, 2, 3 like that. Now see the problem. Now the next step is lay out the machine time for two different jobs corresponding axis. That is x-axis denotes job 1 and y-axis denotes job 2. Okay, now see the graph. Now I am going to lay out machine time for job 1 and job 2 according to the sequence given in the problem. Okay, first let us complete job 1, then we can go for job 2. For job 1, look at the information. Okay, for the first mission, that is for mission A, what is the duration? 3 hours. Okay, start from 0. Start from here. 1, 2, 3. So this is the duration for mission A. Okay, the duration is 3 hours. Okay, see the information. The second sequence is after completion of A, the second sequence is B. What is the duration? 4 hours. Start from here. 1, 2, 3, 4. So this is the duration for mission B. So what is the duration? 4 hours. Okay, now see the information. What is the next process? C. Okay, what is the duration? 2 hours. Start from here. 1, 2. So this is the duration for mission C. 2 hours. Then, so after completion of C, the next sequence is D. The duration is 6 hours. Start from here. 1, 2, 3, 4, 5, 6. Okay. So 6, this is the duration for mission D. Okay, then the last sequence is E. Duration is 2 hours. So start from here. 1, 2. Okay, so this is the duration for mission E, that is 2 hours. After layouting the mission R for job 1, we need to do the same thing for job 2. Okay, now see the first one, B, mission B. What is the duration? 5 hours. Okay, so start from 0. Okay, here 1, 2, 3, 4, 5. So this is the duration for the first mission, that is mission B. What is the duration? 5 hours. Okay, the next process is mission C. Duration is 4 hours. Start from here. 1, 2, 3, 4. So this is the duration for the next mission, that is mission C. Duration is 4 hours. The next sequence is mission A. Duration is 3 hours. Start from here. 1, 2, 3. So this is the duration for mission A. That is 3 hours. Then the next process is mission D. Duration is 2 hours. So start from here. 1, 2. This is for mission D, 2 hours. The next process is mission E. Duration is 6 hours. So start from here. 1, 2, 3, 4, 5, 6. Mission E, duration is 6 hours. Okay. So we have marked duration for job 1 and job 2 according to the sequence given in the problem. Okay. Now see the next step. Now we are going to construct one square or rectangle which will represent the same mission duration for job 1 and job 2. Okay. See, the first mission for job 1 is mission A, and what is the duration? 3 hours. Okay. So now check the same mission duration for job 2. So here we have mission A. What is the duration? 3 hours. Okay. Now we are going to construct one square or rectangle accordingly. See, here A's processing time for job 1 is 3 hours. That is 0 to 3. Okay. Now check the same machine's processing time for job 2. That is A's processing time. Okay, here also the processing time is 3 hours. Okay, that is 9 to 12. Okay, now find the intersecting area of mission A for job 1 and job 2. Okay, for job 1, 0 to 3. No. So from 3, see the dotted line. Okay, for job 2, 9 to 12. So this is the intersecting area. So construct one shaded square. So this shaded square represent mission A's processing time for job 1 and job 2. Okay. In the same manner, we need to construct either square or rectangle for all other missions based on the processing time. Look at the next mission, that is B. Its processing time for job 1 is 4 hours. Okay. That is from 3 to 7. For job 2, B's processing time is 5 hours. That is from 0 to 5. Okay. From 5, see the dotted line. For job 1, from 3 to 7. No. So, this particular area. Okay. So, this is the intersection area for mission B to process job 1 and job 2. Okay. So, you can construct one rectangle like this. Look at the next mission. That is C. Its processing time for job 1 is 2 hours. That is from 7 to 9. Okay. For job 2, C's processing time is 4 hours. That is from 5 to 9. Okay. So from 9, see the dotted line. Okay. For job 1, 7 to 9. No. So see the dotted line from 9. So this is the intersecting area for mission C to process job 1 and job 2. Okay. So you can construct one rectangle like this. In the same way, look at the next mission, that is D. Its processing time for job 1 is 6 hours. That is from 9 to 15. Okay. For job 2, D's processing time is 2 hours. That is from 12 to 14. Okay. From 14, see the dotted line. Okay. For job 1, 9 to 15. No. Okay. See the dotted line from 15. So, this is the intersecting area for mission D to process job 1 and job 2. So, construct one rectangle like this. In the same way, look at the next mission, that is E. Its processing time for job 1 is 2 hours. Okay, that is from 15 to 17. Okay. For job 2, E's processing time is 6 hours. That is from 14 to 20. Okay. From 20, see the dotted line. For job 1, 15 to 17. No. See the dotted line, 15 and 17. So, this is the intersecting area for mission E to process job 1 and job 2. Okay, so you can construct one rectangle like this. So this is the way to construct square or rectangle for all the machines according to the data given in the problem. Now we are going to find out the finishing point for job 1 and job 2. Okay, for job 1, 17 is the finishing point. For job 2, 20 is the finishing point. Okay, so this is the intersecting point for job 1 and job 2. Okay, so this point is called finishing point. The next step is we are going to find out total elapsed time for job 1 and job 2, which includes idle time. Okay, for that we need to draw three types of lines, that is a 45-degree angle line, okay, then horizontal and vertical lines starting from 0 and moving through the various stages of completion point of 5 different machines for job 1 and job 2 till it reaches to the finishing point. Okay, now let me show how to draw these lines. So first you have to start from 0 and we need to draw one 45-degree angle line. For that, just check the finishing point of the first process, that is 3. Okay, from 0 to 3 you can draw one 45-degree angle line. From here, just check the finishing point of the job 2 first process. So this is the finishing point of the first process through machine B. Okay, so from this point to this point you cannot draw 45-degree line. Instead you can draw one vertical line. Okay, so from this point to this point you can draw one vertical line. Then from this point to we have to move further. No, for that just check the finishing point for the job 1 and job 2. Okay, the next finishing point is 7. Here 7, but for the next processing time, finishing time is 9. Okay, so 9 and 7 intersecting. This particular point represent finishing time for C as well as finishing time for D. Okay, for two different jobs. So now you can draw one 45-degree angle line from this point to this point. Okay, the next move is just see the finishing point. The next finishing point is 9. Okay, and here the next finishing point is 12. 12. Okay, so here you cannot draw 45-degree line from this point to this point. Instead, you can connect this point. Okay, so this is the finishing time of C. So you can draw 45-degree line here. From this point to this point, you can draw only vertical line. And then check the next processing finishing time, D, 14. So 14 here, no. So from this point to this point, you can draw only vertical line. Again, from here, you have to go for next move. For that, just check the finishing point. Okay, the finishing point for the next process is 15. 15. And here, the next finishing point is 20. So 20 and 15 intersecting here. Okay, so this particular point represent finishing processing time of E as well as D. Okay, so now you can connect these 2 points with the help of 45-degree angle line. Okay, now job 2 processing is over in this particular point. But for job 1, we have one more process, that is 2 minutes. The last finishing point is 17. No, so 17. From this point to this point, we can draw only horizontal line. Okay, this is the finishing point. No, we have to touch the finishing point right from the 0 to finishing point. Okay, so we have drawn the vertical, horizontal and 45-degree angle line starting from 0 to finishing point. Okay, let's see the calculation of total elapsed time. Okay, so total elapsed time means actual finishing time of job 1 and job 2 plus idle time of job 1 and job 2. Okay, see, job 1, the actual finishing time is 17. Job 2, actual finishing time is 20. Okay, see the graph. For job 1, actual finishing time 17. For job 2, the actual finishing time is 20. Okay, now we need to add idle time for job 1 and job 2. See the graph here. The 45-degree angle line represent processing of two different jobs through different machines. Okay, so here we have 45-degree line, 45-degree line, 45-degree line. Okay, and then here we have two vertical lines and one horizontal line. Okay, so these two vertical line represent idle time for job 1. Okay, and this horizontal line represent idle time for job 2. Okay, now check the duration. The first one is here, idle time for job 1. So what is the duration? From this point to this point, 2 hours duration. So idle time for job 1 is 2 hours, plus here we have from this point to this point, the duration is 3 hours. Okay, so 2 plus 3, 5. That is the idle time for job 1. So we can add here 2 plus 3. So this is the total elapsed time for job 1. Actual completion time plus idle time. Okay, total 22 hours elapsed time. Like that we have to calculate for job 2. So job 2 actual finishing time is 20. No, plus we need to add the idle time of job 2. So this particular horizontal line represents idle time for job 2. What is the duration? From this point to this point, the duration is 2 hours. So we need to add 2 hours idle time along with the actual finishing time. So total 22 hours. So this is the way to calculate total elapsed time for job 1 and job 2. Now let us see the optimum schedule for job 1 and job 2. Let's see optimum schedule for job 1 and job 2 from the graph. Okay. See the first one, job 1. Job 1 processing through 5 different machines. The first one is A. The processing time is 3. Okay. So A processing time 3. 0 plus 3. 3 is the finishing time. And after completion of the first process, job 1 is idle for 2 hours. Right. Okay. So 2 hours. So 3 plus 2, 5. From this particular time, the next process starts. No. So what is the next process? Job 1 processing through machine B. Duration is 4 hours. Okay. So B duration 4 hours. 5 plus 4, 9. This is the completion time. Okay. Through second machine. Then the next processing is C. Through C. Duration is 2 hours. Okay. C duration 2. 9 plus 2, 11. Okay. So after completion of job 1 through machine C, so there is a idle time for job 1. So how many hours? 3 hours duration. So 3 hours idle time. So 11 plus 3, 14. From 14, so processing time starts. Okay, for D. So from here to here, duration is 6 hours. So D, 6 hours. 14 plus 6, 20 hours. Okay. Then finally, the last process is through E. Duration is 2 hours. No. So E, 2 hours duration. 20 plus 2, 22 hours. Okay, this is the total elapsed time. Okay, including idle time for job 1. Now, look at the optimum schedule for job 2. Okay, the first mission is B, duration is 5. So, 0, B, 5. So, 0 plus 5, 5. This is the finishing time. Then, the next mission is C, duration is 4 hours. No, so C, 4 hours. 5 plus 4, 9. Okay, the next mission is A, duration is 3 hours. So A 3 hours, 9 plus 3, 12. The next mission is D, duration is 2 hours. So D 2 hours, 12 plus 2, 14. The next process through E, duration is 6. Okay, so E 6, 14 plus 6, 20. Okay, so after completion of job 2 is idle for how many hours? 2 hours till it reaches to finishing point. Okay, 2 hours idle time. So 2 hours idle time, 20 plus 2, 22. So this is the total elapsed time for job 2 including idle time. Okay. Now let's see the optimum schedule on various machines for job 1 and job 2. Let's see the optimum schedule on various machines for job 1 and job 2. See the first one, mission A, processing job 1 first and then mission A processing job 2 next. Okay. So 1 and then 2. Next one, mission B. So mission B processing job 2 first and then processing job 1. Okay, this is the order, 2 and then 1. Next one, mission C. So mission C processing job 2 first and then processing job 1. So 2 and 1. Then mission D processing job 2 first and then processing job 1. Okay, 2 and 1. And finally, mission E processing job 2 first and then processing job 1. Okay, so 2 and 1. So this is the optimum schedule on various machines for job 1 and job 2. Okay, so this is the way to solve processing 2 jobs through M machines.